Assalamualaikum and very good day to our respectful lecturers Dr. Wan Faidah binti Muhammad Azmi. We are Group 3 and we are here today to present our comparative case studies for the basement construction. Hope you enjoy the show. Before we begin, allow me to take this chance to introduce the members of Group 3. Firstly, we got Amir Hakimi bin Sharif. Next, we got Iyas Dura binti Rahman. The third member is Muhammad Syami Akamal bin Muhammad Sani. And last but not least, I am Muhammad Shazmi bin Muhammad Saad. Throughout this presentation, each member will present different sections of the report, including the project background, case study analysis, comparative analysis, and the key finding and the recommendations. Before we begin with the case studies, let us first understand the importance of basement construction in today's construction industry. Due to rapid urbanization and limited availability of land, on today's construction industry, basement construction has become an effective solution for maximizing land use, especially in densely developed areas. By building below ground level, additional space can be created for parking, plant rooms, storage, and other building service without increasing the building footprint. However, basement construction is more complex than conventional construction. It requires careful planning, deep excavation, effective retaining structure, and proper groundwater control to ensure the safety and the stability of excavation, hence improving the overall construction of the basement. Since every project has a different soil condition, groundwater level, surrounding environment, and selection of construction method, the selection of construction method must be based on the site-specific condition. Therefore, in this case study, we compare two different basement construction projects to evaluate their construction method, engineering challenges, solution, and overall effectiveness in achieving safe and efficient basement construction.
Now, let's moving on to the next part. Let's have a look at our project background of the chosen project. Now, let's dive into our first project breakdown of our selected case study. So, for the first selected project is construction of one unit of a two-story detached bungalow with a basement located at lot 1823 Jalan Pegoh, Kampung Pegoh, Bukit Pegoh, Alor Gajah, Melaka. So this project is designed as a modern luxury residential development consisting of one basement, a ground floor, first floor with a total gross floor area approximately 3,196 square meter. So for the major construction work including the earthwork, basement and retaining wall construction, reinforced concrete structural work, roofing, architecturing, finishing, mechanical and electrical services, plumbing, landscape, and lastly is testing and commissioning. And the main objective of this project are to achieve construction quality, effective cost control, workplace safety, timely project completion, and a sustainable and functional building design for our environment. Next, I will briefly explain regarding parties involved in this project. For the first one, the owner, the client, Dato Hashim Ghani, is responsible for initiating the project, approving the design, providing the financial, and making the key project decision. For the next, the architect is the Azri Design Architect, prepare the architectural design, coordinate consultant, and ensuring design compliance throughout the construction. For the quantity surveyor, ARR QS Consultancy, Sdn Bhd, manage the project cost, prepare the contract documentation, and also the controlling the project budget. So finally, the main contractor is Fuma Building and Engineering Sdn Bhd. They are responsible for managing the construction activity, supervising subcontractor, procuring material, and ensuring that all work comply with the contract requirement.
So I will explain about the basement construction of Colony Infinitum. It's a mixed-up use development located in Chowkit, Kuala Lumpur near the Central Business District. The project was developed by Mickley Equity Sdn Bhd in collaboration with Roxy Pacific Holding Limited. and it contracted between 2050 to 2021. It consists of 56-story tower with a 723 residential unit with 31 commercial unit. One of the key features of this development is 4-story basement. The site is located in highly urbanized area surrounded by existing building, commercial development, and major roads. Because of this construction process requires a careful planning to minimize the distribution of the surrounding environment. One of the major engineering challenge of this project was the geological condition of the site. The area is underlain by the Kuala Lumpur limestone, also known as Skulls Formation, which has irregular rock surface, underground cavities, and fractured bedrock. This condition made excavation and temporary retaining work more difficult compared to normal soil condition. In addition, the tight urban setting increased the complexity of the project, as the structure had to ensure the stability of the excavation and prevent the ground movement that could affect the nearby structure. Next, for this slide, it explains the main parties involved in the construction of Colony by Infinitum basement project and their responsibilities. The client for this project is Macquarie Equity Sdn Bhd. They were responsible for the project financing, defining the project objective, appointing consultant, and the main contractor approving design proposal and make a key decision regarding the scope, cost, and program. The main contractor is Prestige Mega Construction Sdn Bhd. They were responsible for managing the overall construction work on site, coordinating the subcontractor, ensure that all the work carried out according to the approved drawing. And next one is the geotechnical specialist, was the Kelly Asian, was responsible for designing and implementing the excavation support system, soil investigation, and ensuring the stability of the excavation work. After that, the structural and civil consultant was the Perunding Maju Cipta Sdn Bhd, was responsible for the structural and civil design, particularly the interface between the basement and superstructure as well. Overall, this party worked together to ensure the project was delivered safely, efficiently, and accordance to the design and regulation requirement.
Now, I will continue with section 4, which is the case study analysis of our selected project. Firstly, let's look at the design consideration. The building design was influenced by several important factors, including financial, space planning, structural requirement, site condition, and environmental performance, and also compliant with the Malaysian building regulation. Since the project includes a basement, the structural design used a reinforcement concrete system to provide a sufficient strength and stability. In addition, the hilly terrain and rural location require careful earthwork planning and drainage design, and also construction logistics to ensure that the building could be constructed safely and efficiently. Let's continue with the basement construction method. So, this project adopt the open cut excavation method, which is suitable because the site has sufficient working space and also relatively stable soil condition. The construction begins with the site clearing and site setting out, followed by soil stripping to remove unstable topsoil. Excavation is then carried out progressively in stages until requirement basement level is achieved. To maintain excavation stability, better slope form based on the soil condition and continuous inspection are carried out throughout the excavation process. Instead of using a full internal strutting system, this project relies on better slope for stability. However, temporary support such as steel sheet pile or timber planking are provided in localized area whenever additional support is required. Since Malaysian experience frequently rainfall, weather also play an important role in this important project. Excavation work scheduled during dry period only, while temporary drainage system and pumping equipment are prepared to manage rainwater and maintain site safety. Moving on to the material use, the main structural material is reinforced concrete, which is used for the basement slab and retaining wall due to its high strength and durability against earth pressure. So a waterproofing system is also installed to prevent water leaking and protect the basement from moisture damage. So during the excavation, timber and steel support are used temporarily whenever additional lateral support is required. For construction equipment and machinery, excavators are used for the earthwork and material handling, while a hydraulic piling machine is selected because it produces less noise vibration compared to conventional piling method. A water pumping system is also used to control water inside the excavation area, ensuring a dry and stable working platform throughout the construction process. Next, I will explain the testing, inspection, effectiveness, and cost involved in the basement construction. To ensure construction quality and safety daily, survey is carried out to monitor ground movement and excavation level. Nearby buildings are also inspected regularly to detect any settlement or cracking, while all excavation work are supervised by the site supervisor and safety officer to ensure compliance with engineering and safety standard. The open cut excavation method is considered effective. Why? Because it is cost efficient, require fewer temporary support system, allow construction to progress more efficiently. In addition, proper weather planning is also helped to minimize delay by heavy rainfall like the Malaysian weather. The estimation cost for basement construction is approximately 2 million ringgit, covering excavation work, reinforced concrete structure, waterproofing, dewatering system, construction equipment, and contingency costs for the unforeseen site condition. Overall, this method provides a safe, efficient, and economical solution for the basement construction. During construction, several challenges were encountered. The first issue was groundwater, which created wet working conditions, slow excavation progress. Secondly, the hilly terrain require careful excavation sequencing to maintain better slope stability. Finally, heavy rain caused surface runoff water accumulation, affecting both excavation and concreting activity. To overcome this issue, the contractor installed a dewatering system which a temporary drainage applied control excavation to maintain slope stability and schedule critical activity during favorable weather condition. For the future improvement, we recommend the implementation advanced groundwater control system, improving temporary drainage, carrying out early stage slope optimization, and installation real-time monitoring system to further enhance excavation safety and efficiency. Finally, we have ready a video the actual surface water pumping operation during the basement excavation work on project 1. As shown in the footage, water collected inside the open cut excavation after the rainfall. Some pump was used to remove accumulated surface water and maintain a dry working platform. This process is important because it prevents water accumulation, improve site safety, protect excavation stability, and allow excavation and concrete work to continue without minimal delay.
For the design consideration, the colony infiltrum basement project, several key factors were taken into account. First, the complex geology where the soil condition is weak and unpredictable, which affect the overall stability during the excavation. Second is the influence of groundwater, which can reduce the soil strength and compromise the excavation safety by increasing the instability and water ingress. Third is the urban constraint, as the site is surrounded by adjacent building and underground utilities, requiring a strip of the ground movement. Lastly, the deep excavation of the 4-story basement resulting a high lateral earth and water pressure make the stability even more critical. For the construction method, a contiguous bore pile wall is used as the main retaining system due to its high stiffness and low vibration, suitable for the urban environment. Deep soil mixing is applied to improve the weak soil by increasing strength, reducing compressibility, and controlling water-ground flow. Jet grouting is used to enhance the ground strength and form a low permeability soil crate. Column for the groundwater cut-off in variable soil condition. Rock threshold grouting is used to seal a crack and void within the limestone bedrock to improve the rock stability and reduce seepage. Finally, ground anchor replace internal strut to provide lateral support while allowing an unstructured excavation area and improving the construction efficiency. For the material in use in the basement construction, they can divide it into three categories. First is the structural material, which include the reinforcement concrete for the main structural element and high strength reinforcement bar to provide the load resistance and overall structural stability. Second is a grouting and soil improvement material, which include the concrete and grouting works as well as the cement grout used for void filling and improve the ground condition, especially in the weak soil zone. The third one is a protection and durability material, which consists of the waterproofing membranes to prevent the water ingress into the basement structure and corrosion protection system for permanent anchor and to ensure the long-term durability in underground condition. For the equipment and machinery used, they are also grouped as three categories. The first one is excavation equipment, including the rotary ball piling rig for the deep foundation work and hydraulic crawler drilling rigs for excavation and drilling activities. Ground improvement equipment consists of the deep soil mixing rig for the soil stabilization and ground grouting rigs for the strength the ground. Lastly, grouting and support equipment, including the ground pump for the pressure injection works and the ground mixer for preparing cementitious material, ensuring the precise excavation and quality control during basement construction.
I will continue this presentation with the testing, inspection, effectiveness, and last but not least, construction cost involved in the construction of the colony by UiTM Kuala Lumpur. Starting with the testing and inspection, continuous testing and monitoring were carried out throughout the entire construction period. This is to ensure the excavation remains safe and stable in the construction period. Various tests were conducted to evaluate the soil condition, concrete quality, and pile performance, while groundwater level, ground settlement, and retaining wall movement were continuously monitored so that any potential issues could be identified and addressed at an early stage. Moving on to the effectiveness, the integrated retaining system proved to be highly successful in dealing with the challenge of limestone ground condition and the geography of the site. The use of continuous bore pile, deep soil mixing, jet grouting, and rock fissure grouting provided strong excavation support, controlled groundwater effectively, and improved both safety and construction efficiently. Finally, for the last one, the cost of the project. The earth retaining and shoring work were valued at approximately Rm 15 million, although the initial investment were relatively high due to the specialized equipment and advanced construction technique. It helps in reduce the construction risk, minimizing delay that occur, and improve the overall efficiency of the project. This ensure the investment of 50 million is worth the money and ensuring a better performance of the construction of the basement. Now, I shall continue with the main problems encountered during the basement construction and the solution implemented to overcome them. For the first one, we have the challenge of high groundwater level. Continuous groundwater level inflow created unstable working condition and slow down the excavation process for the project. To solve this issue, a dewatering system and a temporary drainage were installed to keep the excavation dry, safe, and suitable for construction activities. For the second challenges was the hilly terrain, which make it's difficult to maintain stable excavation slopes and require careful planning and excavation sequences. This was solved by using a controlled cut and fill method, allowing the site to be excavated in stages while creating a stable working platform for the safety. For the third one, we have challenge of heavy rainfall, which cause surface runoff, water ponding, and affecting the quality of the concrete works. To minimize this, the The impact of construction schedule was planned according to the weather forecasted. Excavation and concreting were carried out during the dry period, while non-critical activities were performed during rainy weathers. Based on these challenges, several recommendations are proposed for the future project. This includes the implementation of more advanced groundwater control system, carrying out early site grading and slope optimization. The third one, improving temporary drainage and surface water management. And last is adopting a real-time monitoring system to detect potential problem at an early stage. Overall, these solutions and recommendations help improve construction safety, minimizing delays, and ensure the successful completion of the basement works.
Assalamualaikum. My name is Yastura binti Rahman and I will be present comparative analysis between the two-story detached bungalow with a basement in Alor Gajah, Melaka and the colony by Infinitum, Kuala Lumpur. Now, let's begin with the similarities between these two projects. Although the projects were constructed under different site conditions, both share the same objective, which was to construct a safe and durable basement structure. Both projects involve reinforcement concrete basement construction and started with geotechnical investigation before excavation works. In addition, both projects implemented groundwater management, waterproofing system, and continuous testing and monitoring throughout construction to ensure excavation stability and structural safety. However, there were also several important differences. Project 1 was constructed on relatively competent soil with a slightly hilly terrain, while Project 2 was located in a dense urban area underlined by Kuala Lumpur limestone, which presented much more challenging geological conditions. These different site conditions influence the construction method, equipment, construction complexity, and overall project cost. Overall, although both projects had the same construction objective, they adopted different engineering approaches to suit their respective site conditions. Now, let's look at why different construction methods were selected for these two projects. As shown in the diagram, the selection of basement construction method was mainly influenced by the site condition. For project 1, the site consisted of relatively competent soil with sufficient working space. Therefore, the open cut excavation method was selected because it was practical, economical, and suitable for the ground condition. The construction process was supported by temporary drainage system, groundwater pumping, and limited temporary retaining structure. This resulted in lower construction costs and reduced technical complexity while still achieving good construction performance. On the other hand, Project 2 was built on a limestone geology within a dense urban environment. Due to irregular rock formation, groundwater seepage, and nearby buildings, the project required a more advanced engineering solution. Therefore, contiguous both pile walls, deep soil missing, jet grouting, rock fissure grouting, and ground anchor were adopted to improve excavation stability, control groundwater, and minimize ground movement. Although this approach involved a higher initial investment, it provides better structural stability, improved groundwater control, and greater protection to the surrounding structure. This comparison clearly shows that there is no single construction method suitable for every basement project. Instead, the construction method should always be selected based on the geological condition, groundwater behavior, surrounding environment, and project requirement. Finally, I would like to summarize the key findings and recommendation for this comparative study. The first key finding is the site condition are the most important factor when selecting basement construction method. The second finding is that effective groundwater management is essential to maintain excavation stability and ensure safe construction activities. The study also shows that continuous testing, inspection, and monitoring are important for maintaining construction quality and reducing project risk. Finally, although advanced retaining systems require a higher initial investment, they provide better long-term performance, especially for projects with difficult geological conditions. Based on this finding, several recommendations can be made. for future basement construction project. Firstly, detailed geotechnical investigation should always be carried out before construction begin. Secondly, groundwater management system should be continuously improved to minimize excavation risk. The adoption of building information modeling or known as BIM together with digital monitoring technologies should also be encouraged to improve planning and project coordination. Lastly, construction methods should always be selected according to the site's geological condition while maintaining comprehensive testing and monitoring throughout the construction process. In conclusion, this comparative study demonstrates that successful basement construction depend on selecting engineering solutions that are more suitable for the specific site condition rather than applying a single construction method to every project.
In conclusion, this study has shown that basement construction is a process which is complex and require careful planning, appropriate engineering design, and effective construction control. Through the comparison of the two case studies we used, we found that there are no single construction method that are suitable for every project. Instead, the most appropriate method should always be selected based on the project site condition, including the soil characteristic, groundwater level, excavation depth, and the surrounding environment. The both case study also demonstrate the proper excavation technique, retaining system, and groundwater control that are essential to achieve a stable and safe basement structure. In addition, good planning and monitoring of effective risk management play an important role in construction safety and enhance the overall performance. Overall, this assignment has enhanced our understanding and the practical aspect of basement construction and highlighted the importance of selecting engineering solution and the best suit requirement of each project.
Alhamdulillah, let's conclude our presentation today. Thank you for your time and attention to watch our presentation. We hope that this video will be informative and insightful for you guys. Thank you and have a great day. Assalamualaikum.